So in today's class, we talked about smoothing using the Gaussian method, which is essentially just a Gaussian blur. Um, so how the Gaussian blur works is through a convolution. The example that was given to us by Dr. Lee was basically a small transformation, a 3x3 grid, and we overlay this 3x3 grid on top of a large image, and we try to calculate the partial product from this 3x3 grid. Once we find all the partial product, we add it together, and then that will give us the new value for the new image. And we do this for every single pixel of the original image to get the new image. So it's fairly simple, and is Gaussian in the way that the kernel has highest probability in the center and gradually spread out to the edges of the kernel. So that's my understanding of the Gaussian blur. But the example that's provided to us actually it's unweighted average. So every single cell in the kernel has the same number. So it adds up to the same product. So in the example that was given in class, what happens to actually remove the noise? It doesn't actually remove the noise. It merely smears out the noise, so the values are more distributed. The noise values are more distributed in the image, so it's less noticeable, but the noise is still there. And that's my understanding of it. The particularly challenging part was the formula for convolution. Because it's done in 2 dimensions, so we have 2 sums, and we use the notation m and n. M is the width of the kernel, and n is the length of the kernel. So we go from left to right, bottom to up, and calculate all the partial products in the kernel, and we add them up. So the formula, the mathematical formula, is sum of negative m to positive m, so every single pixel in the kernel, and the sum of negative n to positive n, every single pixel in the kernel in length, and then we do the function of x minus x prime, y minus y prime. So we take this function and we multiply that by t of x prime y prime. So t of x prime y prime is the kernel, and f is the original image. So this way we add up all the products, and then we get a new value, and that new value is gxy, which is what we're looking for. I think that's it.